Now let us discuss about the chain rule. So we start with the general power rule, and if there is an inner friction, then we have to find, the outer friction, the derivative of the outer friction multiplied by the derivative of the inner friction. Let's use this one. If u of x is a differentiable friction n is any real number and y is equal to f of x is u of x to the n power. Now the derivative of this one is f derivative at x is n times the derivative of the inner one, n minus 1, multiplied by the this derivative of the inner, that is the derivative of the inner one. So this is the chain rule, or we can write a simplified form or a simplified notation. Y prime is n un minus 1 times u prime, or dy by, let's say, this one, d by dx of u to the n is n u n minus 1 times du by dx. Generally, this is the inner friction. The general one is, we call it the outer friction. So this is the chain rule. Now let's use example to clarify this one. For example here, let's solve different example. Find the derivatives of the following fractions. Let's start from, let's say, a. Find f derivative at x for f of x is, let's say, 6x plus 7 to the fifth. When you look at this one, this is u, right? Then what is the derivative of this one is 5, according to the power rule. 5 down, 6x plus 7, 5 minus 1 is 4. The derivative of the inner fraction is d by dx of 6x plus 7. Now this becomes 6x plus 7 to the 4th. The derivative of the inner fraction is just 6. Look at this one, the derivative of the inner. Then we can write this one as, since 5 times 6 is 30, 6x plus 7 to the 4th. So this is the derivative of this fraction. All right. The second one, for example, B, find f derivative at x, given that, for example, for f of x is 5 minus 9x to 9x squared. Let's see this one, 9x squared to the 4th power. Now look at this one. What is u? or the inner one is this one, right? So f derivative at x is 4 down, according to the power rule, 5 minus 9x squared. 4 minus 1 is 3. D by dx of, or the derivative of the inner fraction. Now this one is 4, 5 minus 9x squared to the third. The derivative of the inner one is, this one, minus 18x. Look at. Generally, we can simplify 4 times minus 18 is just minus 72. X 5 minus 9x squared to the third, which is the derivative of the fraction. That is the derivative. Look at the derivative of the inner fraction. Let's see another example. Find f derivative at x for f of x is 5 minus 7x to the 12th power. Now the derivative of this one is 12 down here, 5 minus 7x, 12 minus 1 is 11, and the derivative of the inner fraction, which is 5 minus 7x. Now this one is 12, 5 minus 7x to the 11th, and the derivative is just negative 7. See this one. Now when you simplify this one, 12 minus 7 is minus 84. 5 minus 7x to 11 power. So this is the derivative of the fraction. Let's continue. D, for example, f of x, find, let's see, let me write a question. Find f derivative at x for f of x, let's say 3x to the 6 plus 7 to the 4th. Now f derivative at x is 4 multiplied by 3x to the 6 plus 7. 4 minus 1 is 3, multiplied by the d by dx of the inner is 3x to the 6 plus 7. Now this is 4, 3x to the 6 plus 7 to the third. The derivative of the inner one is 18x to the 5th c. Now I can multiply 4 times 18. It is 72x to the 5th, 33x to the 6th plus 7 to the third power. That is the derivative. All right, E. Find f derivative at x for f of x is 6 times the square root of 3x squared plus 5. Remember, now this one is a square root, so you have to set up first the fraction as a power fraction form. 6, 3x squared plus 5, 1 over 2. Now look at the inner fraction. Now this means the derivative of this one is 6 multiplied by 1 over 2 and 3x squared plus 5, 1 over 2 minus 1 multiplied by the derivative of the inner fraction is 3x squared plus 5. This means 6 times 1 over 2 is 3, 3x squared plus 5, 1 over 2 minus 1 is negative 1 over 2, and the derivative of 3x squared plus 5 is 6x. Do you see this? Then this becomes 18x 3x squared plus 5 negative half. Or this can be written as a positive exponent 18x divided by the radical of 3x squared plus 5 as a positive, or in terms of radical form. All right. Let me